Hi everyone. This is the continuation of Deadlock. Under Deadlock, we have seen the characteristics and resource allocation graph, and we have seen how to construct an resource allocation graph, and we have seen an example of the resource allocation graph which contains a cycle and which has a cycle and deadlock free. These are the outputs of that resource allocation graph. That from a RAG graph we can conclude that if graph contains no cycle, there is no possibility of occurrence of deadlock, and if a graph contains a cycle, and if that cycle if only one instance of the resource is available, then there is an occurrence of deadlock, and if several instances of resource types are available in that cycle, then there is only a possibility of occurrence of deadlock. We can't assure that the system will for sure fall in a deadlock state. This is the outcome from analyzing the resource allocation graph. Now we are going to enter into methods of handling deadlock. As I said, there are methods of handling deadlock consist of 4 steps. That is nothing but deadlock prevention, deadlock avoidance, and deadlock detection, and followed by deadlock recovery. In this, the first solution is that we have to ensure that the system will never enter into a deadlock state. For that, two methods will be used, that is nothing but deadlock prevention and deadlock avoidance. Before the system getting entered into the deadlock state, the allocation of the process and resources will be checked rigorously, and the deadlock free states of the resources will get allocated for that resources. That is the deadlock prevention and avoidance. Then the second solution is that it allows the system to enter into a deadlock state, and then it will detect the deadlock and recover the deadlock. So thus the deadlock detection and recovery will be applied for this scenario. And the third case is nothing but if a system enters into a deadlock state, it ignores the problem and pretends the deadlock never occurs in the system. This is at most used by the OS including Unix. For example, if a system enters into the deadlock state, it get completely stopped and pretend that nothing has happened, and the allocation of the resources will be started again. This is followed in the most operating systems. These are the things which we have discussed earlier. If we are dealing with a deadlock problem, there are only 3 ways. We can use a protocol to prevent and avoid deadlock and ensure that the system will never enter a deadlock state, or else we can allow the system to enter into a deadlock state, detect it and recover the system from deadlock, or else we can ignore the problem altogether and pretend the deadlock has never occurred on the system. These are the 3 solutions for a deadlock problem. Thus, in this, let us see the resource which is getting allocated for the deadlock. Based on the resource allocation, there are 2 categories. In this, the resource which is getting allocated, if it is of single instance, the single instance of resource is detected, and the allocation of this deadlock free state is done using RAG. That is nothing but resource allocation graph. For example, single instance resource can be freed from deadlock state using RAG, resource allocation graph, but it is of multiple instance resource, then the deadlock free state can be occurred by using Banker's algorithm. these are the two methods of deadlock avoidance. That is, for a single instance of resources, the deadlock avoidance will be done using resource allocation graph, and for an multiple instance resources, the deadlock avoidance will be implemented using Banker's algorithm. Let's see on the further session.